Random access memory, or RAM, is the workspace for the CPU. The type of memory that we install is known as dynamic RAM, or DRAM. DRAM is volatile, meaning it does not store its contents after a refresh or a restart. To keep the data after a computer restart, we need to use a hard drive or other long-term storage medium. The sticks of RAM in the figure are called DIMMs, or dual inline memory modules. In these videos, we'll concentrate on DIMMs, as they are the majority of the RAM that serves the CPU. Now, the great thing about DRAM like this is that the CPU has equal access to all of the contents, and it can grab any piece of information it wants at any time. It does not have to do it sequentially. Even if you have 32 gigabytes or 64 or 128 gigabytes of RAM, the quantity doesn't matter. It's like having this super enormous giant workbench for projects, but also the ability to work at any part of that workbench at any time immediately. The problem with the CPU and RAM is that they have sort of a closed relationship. To enable that immediate transfer of data between the DRAM sticks and the CPU, we need what we call the memory controller. In today's computers, the memory controller is actually integrated into the CPU itself. The memory controller is the go-between, or liaison, if you will, for the CPU and the RAM. It's responsible for storing data to RAM and locating and fetching data from RAM. It does this by use of the address bus, which is the circuitry that connects the CPU to the DRAM slots. Your CPU's memory controller, and therefore the CPU itself, and your motherboard especially, must all be compatible with the RAM you want to use. So know it, the CPU's memory controller is in charge of storing data to RAM. Now let's get to the fun stuff, diagrams. This diagram kind of puts it all together for a computer system that you might be working with. And this is basically what we call the chipset diagram. On the upper right, we have our DRAM. In this case, it's DDR4, double data rate 4 memory that runs at 2133 megahertz. The DDR4 memory connects to our Core i7 CPU that we have here by way of the address bus. Data flow between the RAM and the CPU is governed by the memory controller, which is part of the CPU. Next, the CPU then connects out to the PCI Express bus on the left and to the chipset by way of the Direct Media Interface, or DMI bus. The chipset then connects out to all secondary devices and interfaces. So you have connections out for audio, the minor PCI Express slots, SATA, the USB ports, the integrated network connection, the firmware, the BIOS/UEFI, and so on. So your chipset takes care of all those secondary connections, and it has a main connection to the CPU via the DMI, or Direct Media Interface bus. And again, that CPU has the connectivity directly out to our video card, our PCI Express 3.0 or higher connections, and out to the memory directly via the address bus. So remember that the sticks of DRAM that we install are DIMMs, dual inline memory modules, and that DDR, or double data rate, is the type of memory that we usually make use of, which we'll speak more about in an upcoming video.